Hey there, everyone. My name's Dan. Here's a presentation here. If you want to take your cameras out right now, if you'd like, I can be right next to the QR code and smile at you. So in this presentation, also here's the where the code's going to be. Slides are going to be here as well. We're going to talk about domain-driven design. We're going to talk about subdomains, ubiquitous language, where that comes from, bounded context, integrating bounded context, simple application, complex applications, and where does that lead to? And then we'll talk about event storming. One category that I don't have here is like, where does that lead to? And I do believe this is absolutely the key to just about everything. So whatever it is you do at work, however architecture is laid out, domain-driven design is where it's at. So set of tools that assist you in designing and implementing software that delivers high value, both strategically, which we'll be talking about, and tactically. And the idea for this is, what is it that we're going to be focused on? What is it that we're designing for? How do we map this with a business domain? It's about organizing code artifacts, and it's about taking a business language, which we're going to be calling the ubiquitous language, and creating models from them. Huge advantages for doing this: incremental and flexible, organized. And the idea here is that you focus on the domain. The domain is going to be how you model your software after the business. Okay, and that's the thing that you're going to be focusing on. The rest is going to be an outside or outside, still important, but how does the business work? Some disadvantages though: learning curve. There's a bit of a steep learning curve, but everything is worth it because everything is like built around that. So when we think about microservices as well, microservices are going to be built around this idea of a bounded context. Although they were developed at certain times, time and effort is going to be involved as well. So two parts of DDD. One is the strategic, which is what is it that we are going to be doing? The other part is going to be our tactical, which is how is it that we're going to go about doing it? The strategic, I don't think, is ever going to change quite that much. It is what it is. And, pretty good solid foundation there. Tactical is always going to be changing. And, how do we architect systems? There's always going to be a new, fresh perspective. And one of those new, fresh perspectives was AI. Like, how do you include AI in all this? How do you include MCP servers and RAG systems and all that, newfangled technologies that are around there. Where do you not use DDD? I think if you have a small project, DDD is probably not going to be the thing that is going to be paramount. This is really for large systems. This is really for large companies. But in the end, some of the techniques that you learned here can be applied also to some of the smaller systems. And so that's something worth noting here as well. There's a wonderful website, github.com/DDD crew. So make a note of that. This has lots of different templates and pictures and little booklets like Welcome to DDD. And it's the domain-driven design crew. Again, take a look at github.com/DDD crew. Wonderful thing that you could use there. All right. Let's start off now with subdomain. So one of the things that you talk about is, what does your business do? Because you are modeling the software against what they do, okay? So if you're FedEx, you're a shipping company. And we heard of some other companies this morning as to what they do. Starbucks does coffee, Walmart does retail, and on. We heard about Toast. What a wonderful business that is, something that is wrapped around menus and ordering and even the back kitchen, which I wasn't fully aware of. That's a business domain. That's the thing that you are writing software for. And identifying it is an important thing as well. Then there are ancillary domains, right? For example, Amazon, right? What is Amazon? Back, in the starting of the internet, Amazon was just a bookstore. Like, that was their primary business. But then Amazon just is everywhere. Do you have like Amazon trucks here in India? Like, here in the United States, we have like delivery, so they've taken on delivery as well. So FedEx and UPS, what we have in the U.S. is getting some stiff competition from Amazon. So Amazon seems to have their hands in just about everything. Uber does food delivery with Uber Eats in the US. I don't know if they have the same thing here. So things change over time, right? For all of you familiar with Nintendo, Nintendo was like a playing card company, right? So things change all the time. So one of the things you'll want to identify, and part of DDD, is identifying what the subdomains are, which are really just, partitions of what your business does, okay? The fine-grained area of business activity, right? We talk about monoliths in the technological space, but what about that business space or the problem space? Your business, the business that you work for, has different subsections of that, and those are called subdomains, okay? Provides a service, and they have to interact with one another. What are they? Have you ever asked, right? Those are important things that you would have to take a look at. So Starbucks is great at coffee. But I know in the US, and I know you have some Starbucks here. I saw one. I may just go there a little bit later. But if you ever been to especially an American city, particularly in the center of town, there's a Starbucks right there, and then there's a Starbucks right over here, just, across the corner of an intersection. Why did they do that? Well, because they know what they're doing, right? They know foot traffic, and how it is that they're going to, the customers, how are they going to walk to them? Maybe they don't want to cross this tight intersection there. They don't want overflow. So they have a very good reason why they do that. And so they're really good at real estate. Did you know Starbucks hires super tasters, and they get paid very well? So if you think you have what it takes, I was doing a thing that were like one of my customers of a customer, and they gave me a tour there, and they say, yeah, we'll pay heavily for people who can really, really taste coffee, and then you'll go through trials or whatever. But that's another facet of what they do. Tasting. Oh, that's amazing. Hiring personnel, managing finances, other activities. 3 types of subdomains that you'll want to take a look at within your company. What are they? Again, you have subsections within your company. One is core. Core is the complex stuff within your company. That's, think about the subdivision that makes money, that has a particularly hard problem. It is complex, and it's hard for your customers to mimic, okay? And that's the one that deserves the most attention within your particular company. And it doesn't have to be technical. One of my first jobs as a programmer administrator, the guy that got under your desk and made sure the connection was, I was the every guy at this company. And what they did was that they climbed radio towers for cell phones, which is a hard job. But that's the thing that brought everyone money. It wasn't technical, but it was extremely hard work. If you were in a mountainous area, I think that ended up kind of easy, because cell phone towers and radio towers would typically be on top of the mountain, right? And so that would be kind of easy to climb up. The harder ones were like in the plains of the U.S. We're talking like Nebraska and South Dakota and North Dakota, because those would be flat lands, and the towers had to be much, much higher, and it was cold and windy, right? And you think about that, that's a difficult thing. So your businesses have a difficult thing. A successful business has found a way to do that, and that's your core. Identify that, okay? Next will be the generic, okay? Things that companies are doing the same way. And so I'll just jump right here to the bottom. Authenticating users. Who does that, right? A lot of companies will just flat out just go for Okta, for something like that. Maybe you have software for organizing your day. Some of you have Workday, some of you have Zscaler, some of you have, all these other software. Those are generic domains. You do need someone in-house to manage these particular domains and these software units, but they have already been developed, okay? And so that would be a generic subdomain. Supporting is, I think, the important one, the huge important one, because we're now at this moment of AI, right? And a lot of companies, I believe, very strongly, erroneously, are stating that AI is going to come take away your programmer jobs. But the reason why I believe that's erroneous is who are you going to hire for the core, right? Core is the difficult stuff. And if you're programming for that core, where are you going to find those programmers? Are you just going to go out and just, find those programmers and bring them in off the street? And sorry about the term there, but you know what I mean? Just, from the outside, do they know everything about your domain, right? The value of the junior programmers is you get to nurture them. You get to tell them the way your software products are designed, but then they end up learning about your domain. So one of the questions that we get in the States is like, how do we deal with the new world in programming, right? Someone I mentioned their son is graduating, but, can they still find good jobs in programming? Well, a lot of times this is, and I'm sure all of you already know this by now because you're in that kind of job, your programming is mixed with a domain, right? I'm working for the medical industry. I'm working for a retailer, food retail like Toast, right? There's always a complement to it as well. And so a programmer would have to know that particular domain, okay? Now, supporting subdomains are not complicated. They are useful, and they are supporting. So they do a lot of ETL, which is extract, transform, load, generate CRUD-based applications. And that's the idea for a supporting subdomain. I love this one, and I love this book as well. So most of these images here come from this wonderful book, and it's called Learning Domain-Driven Design, and pick that up. I think the only thing that's wrong with it is like most of the examples are .NET, but it's fine. I translated them to Java, and we'll take a look at some Java ones here in a bit. But I absolutely love this graph, right? Supporting are your junior programmers. They develop applications that support the core. Business differentiation. High, meaning they do something different than anybody else. Low, they're not doing something different as with everyone else. Business logic complexity. You'll notice that the core is over on the upper right-hand side. They do things that are complex, and they do things different from other businesses. Supporting does things different than other businesses because their job is to support that particular core, right? Should make sense there. But the generic side is like, hey, we're doing security. We're doing authentication. We're doing workday management. We're doing blah, 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 right? Some of the standard things that you see, or accounting, right? Things that you see over and over again are going to be there on the generic side. But you need all these different kinds of components, okay? So here's this table here. What is the subdomain? Does it have a competitive advantage? Is it complex? Is it volatile? Volatile meaning if you are doing something and it's highly competitive, do you have to change very quickly? The answer is high for core, which would make sense. Your implementation in-house, generic would be buy or adopt. Supporting would be in-house or, outsource that because things are particularly obvious. Cool, right? First part there. Next, identifying who the domain experts are. And they're not us, right? They're not the programmers. They are the people that are running that particular business. They're called subject matter experts. Knowledge authorities in your business domain. They are not analysts. They're not engineers. They're not DevOps. They're not, any of the technical people. They are the ones that will run that particular business, okay? And what they do is they have an understanding about that particular subdomain that they are working on, okay? And that's the important part. All right, so you find who those people are, and what you'll do then is start with this part. This is part of the strategic here, which is called the ubiquitous language. Ubiquitous language is how do they speak, okay, within their business. So one of the things that I like to talk about a lot is behavior-driven development. And one of the things about behavior-driven development is you have a product owner, which is an ambassador to the stakeholders for your particular business, testers, developers. And what you do is you come up with statements as to what your business is doing. But during this time, one of the things that you'll do is you'll establish what's called the ubiquitous language. And that's a core concept of domain-driven design, which is what are the terms you use? What are some statements that you make as to how your company operates? Tell that to me in your own language. And that's where that comes in. So you provide a dictionary of that language. You write down sentences of what they say. Like, we're going to have a shipment, and that shipment should be delivered in 45 days. I'm oversimplifying, but that would be a statement of fact, a statement of clarity that you can base your software on, right? And you know what it is that they're doing. So language for describing the business domain represents both the business domain and the domain experts, their mental models as to how they describe it. Okay? Don't put any technical jargon in it. No, hey, this is REST, right? Or we have an index on this. This is an indexed idea, or like this is a Kubernetes pod, right? None of those things really reflect the business or the business model. That's part of what we call a solution space, and more on that a little bit later. Okay. And so they should be consistent. And this is where things are going to start to drive apart. And you're going to be taking down those terms, which is ubiquitous language, write those down and take a look at them on a board or something, and then decide where things might show some cracks. And where are those cracks going to happen? Well, one of the things you're going to look for are things like ambiguous terms and synonymous terms. That's where they start to come in. And so what are those? Policy, right? What's a policy? It could be a regulatory rule, could be an insurance contract, a little fine-grained distance there. But what does that mean, and how do we separate that? But we also have things like user, admin, visitor, account, right? Those are different terms that different domains could be using as well, right? And so in divisions of the company, you're going to find that everybody has their own separate language, right? Accountants have their own language. We have our own language, right? You ever talk to somebody who isn't, a developer, and you start spouting out some of these terms, and they're like, I don't know what they just said. You feel like really important about it, right? Because we have our own ubiquitous language in how we talk about that. Find the terms that they're using and use that in everything. So documents, tests, requirements, source code. Don't go with your own terms. Oh, I think they should call it this, right? I'm totally guilty of that. But use their terms, make it the centerpiece, and make it a source of truth. Make sure you have a glossary for that. Now, you have this, and then one of the things you could do is you can start to really interrogate that particular business and ask, what is it that they do? And you'll be providing this given when and then. How many of you do gherkins or have seen gherkins? Okay. This is part of what's called acceptance testing, which is, hey, given the account balance of $23.93, when a message balance comes in from 404,333,222, then the text is sent back, your balance is $23.95, right? Given a particular situation, when an action happens, then this is the result of what should be happening, right? And you start interrogating it. It looks like overly simplified, or like, I don't want to waste my time with this. But if you ever do these sessions, they become really, really exciting, because then all of a sudden you turn into a lawyer, which is like, where were you? And where were you on this date? And things like that. But the more on the business side, all right. What happens if we do this? What's going to happen in that particular condition? Then they start to sweat like I am right now. But then they'll start to say, I really don't know. That's never come up. All right. How many of you have been in a situation where a stakeholder says, oh, that never happens. That never came up. What happens the next week, right? That situation comes up. So enshrine that in a BDD. And then the idea for BDD is that given this, you wire that in and you glue it. I'll have an example for that. You glue that code to your Java code, and you start to bind this with your domain layer, okay? And see that come to fruition. So whatever you get from your acceptance testing, make that a part of your TDD, and which, by the way, in this day and age, TDD is getting a lot simpler now with the use of AI as well. So before, if TDD was always a pain, I think that pain has greatly been alleviated just because AI can do a lot for you. Okay, cool. Now we move on to bounded context. All right, so you have that ubiquitous language, you find out that the domain experts' ideas and terms are going to be inconsistent. You find that they're using synonymous terms. It may be hard to detect initially, but, few terms may be, something that you look at and you're like, I don't know. It was particularly account, different subdomains within the organization can have like a different idea of what an account is. Maybe account is something that one organization signs in over to. So we hook into an account for ChatGPT, but maybe another organization uses an account for signing into their system, right? There's that slight difference there of what that account is. And it's going to be your job to find out what that is, right? And that's one of the harder parts here. So one of the fun questions I usually ask, I have a big audience here, and most of the folks are from India. So I think I already know what the answer is. But over in the States, we get a mixture of people from all over the world. And so, I'll ask someone with a non-American accent, hey, what's your favorite football team? Right? And I know what it's likely going to be. I don't know what that answer is going to be, but it's going to be some what we call soccer, right? And so they'll say, oh, I like Madrid Real, or, one of the soccer teams from Europe or from India or things like that. And we have soccer in the U.S., but it's probably not as popular as the NFL, which is football as well. Do we have a bounded context? Yes, absolutely we do, right? Depending on who you're asking, what bounded context we're working on, we have this, ambiguous term. It's called football. But same sort of notion even with its own company, right? And so that's what we want to look for. Like lead, what does a lead mean? And so everyone has their own way to deal with that. So one of the things about how we do things and what DDD forces us to do is not think about an ERD. One of my failed projects was me doing this. I thought a model has to bring everything in, right? And everything that is linked to one another. That's just madness, because you bringing in an object graph with everything in the world is going to make your life so hard, right? And so the idea for this is to wrap things up in a bounded context that could make things useful. Now, let's say lead, which comes from the book, which is, do I want to say marketing lead or do I want to say sales lead? No, that's too much work, right? That's too much of a cognitive load. Why should we add that particular prefix here? Hey, I enjoy football. Which football? Right. So, that's an additional term that we would use there. So prefixing is not going to work very well. And this is where bounded context comes in, right? You have the European League. Do you have like an Indian football league as well? I assume so as well, right? An American has a soccer league, but it's the same as football league. But again, different context there. In the U.S., we call it soccer, right? Same thing, but different bounded context. Same thing within your business. And this becomes essentially the most important part about doing DDD, is that you find these contexts where lead could be even something minuscule like an event, and on one other context, it could be an entity, okay? And you have different model representations for whatever it is that you need. So am I looking at a subway map? Am I looking at a world map? Am I looking at a naval navigation map, or whatever the one on the bottom left-hand side is? I got a few different renderings of, particularly New York, except for the one on the upper right. But what is your representation? What is your model? And the thing is about a model is that that's just really representation of your business. How fine-grained or how coarse-grained is going to be up to you. That's part of that particular business context, or bounded context. Within that bounded context, you have your language, right? In the US, we have soccer. In India, you have football. In Europe, you have football, right? Or everywhere else in the world. And their context, they call it football. But there is a ubiquitous language in there. Is it universal? No, not at all. But is it ubiquitous within a particular bounded context? The answer is absolutely yes. And that's where that comes in, okay? How big should it be? How small should it be? Up to you. And if you go too big, then you end up in that kind of monolithic style of software. If you go too small, you're going to have over communication between all the different kind of small contexts that are available. So your trade-off is up to you. How big or how small do you want it to be? Now, the tough part here, which is how do bounded contexts and subdomains relate to one another? Yikes, right? And you may get the original domain-driven design book, or you may get Vlad's book, or you may get Vernon Vaughn's books, and they have different ways to describe the subdomains and bounded context. Vernon Vaughn has a one that he mentions the problem space and the solution space. At first, I didn't really buy that term, but now I'm all in with that particular term. So subdomains, of course, supporting generic, interrelated use cases defined by business domain and system requirements. Bounded context design, a strategic design decision on the engineer. That's going to be the important part there. We decide how to divide a business domain into smaller, manageable, really solution domains. I should probably change that term there from because the problem is the subdomains and the solution is the bounded context. What am I saying? So here's how that works. When you identify the business, now the business operates, that's called the problem domain. That's who you're solving that for. How you go about doing that is your bounded context. This is you. This is your technical side. That's how you figure that out, okay? And you may get a one-to-one match on it. So I have a core subdomain of whatever the company does, right? Let's say Starbucks, where we have a bounded context that represents the coffee. That's a one-to-one match, and we can write software for that. That doesn't mean it's reality as far as the technical deployments. So for, in other words, a bounded context may be using, maybe written for a generic subdomain and a little bit of a supporting domain, right? They're going to be using a system that is housed within this particular bounded context. There's a little bit of degree of difficulty in having one, bounded context servicing multiple subdomains, but it's going to happen, right? Think of it like an ERD system or something that manages, all the employees, right? That's going to be shared across multiple subdomains, perhaps. So how you technically divide things may not necessarily match up to your problem space, which is how the company operates, okay? And that's why you have both levels there, okay? So as far as the bounded context, you have physical boundaries and you have ownership boundaries, okay? Each bounded context should be implemented as a project. Clear physical boundaries between bounded contexts. Implemented, evolved, and versioned independently from other bounded context. Now, keep in mind, this came out in 2003, and the idea for a microservice came out in 2011. So there's a little bit of a gap right in there. But this sounds really familiar, doesn't it? Okay. Bounded context can contain multiple subdomains, just as we stated. Logical boundaries bear different names, and we could use namespaces, modules, things like that. Now, interesting on the ownership boundaries. So all those are physical boundaries. Next are the ownership boundaries. Bounded context should be implemented, evolved, and maintained by one team. Oh, look at that. That sounds really familiar, doesn't it? Right? Microservices are owned by one team as well. This seems like it's almost about to fit. Almost. We'll see. So no two teams can work on the same bounded context. Oh, all right. That's another micro that I hope typically is obeyed. And why is that? That's because the team knows that particular language, right? That ubiquitous language. They get really good at that. And you want that. You want those teams to be very excellent at what they do and that one particular microservice. Segregation eliminates implicit assumptions that teams may make about each other's models, right? And that's the idea for that. Cool. So one team can operate on multiple bounded contexts or just one particular bounded context. So again, one came out, bounded context and DDD came out in 2003. Microservices came out in 2011, but they are a complement to one another, okay? Remember the rules on the physical and ownership boundaries. And I love this term here. This isn't from the book. This is the way I see it, I guess. One is a conceptual boundary. That's the bounded context. How is it in your solution space are you going to be dividing up the business? Microservices, how you deploy that. That's just a deployable unit, okay? That's kind of the way I see it. But the bounded context is a term that we've been using a lot more, and you'll see that in a lot of blogs and other items like that, where we talk about the bounded context. And I guess our brains will kind of like switch between that bounded context and microservice, but one's more technical, one is based around the business, okay? And what that deployable unit is. And I think this part is really, really important here. And that is when you derive your bounded context, you have a sealed area that is managing a particular part of a business in a technical way, right? How do you deploy that? Well, you could have one bounded context with one deployable unit, or two bounded contexts within a deployable unit, or 5 different bounded contexts in one particular deployable unit. That choice is yours, right? And if you take a look at the left-hand side, what is that? That's the thing that people are calling nowadays modular monoliths, right? Which is you still have your modules, you still have your bounded context, but you could deploy that as one service, right? And then you would have a communication between all these bounded contexts. What makes things great here is that if you wish to pull things apart inevitably, they're already self-sealed in their own particular space, that if you wish to just say, send that over to its own deployable unit, you could do so, right? And that's that relationship. And it worked out nicely, even though one began in 2003 and the other one began in 2011, okay? And these contexts are neither big or small. It's useful to you. How do you wish to decide, which things are related? So in the case from Learning Domain-Driven Design, here's an image here, and they deem that creatives and acquisition should be related to each other. So how is that bounded context going to work? Okay, cool. Whew. All right. Integrating these bounded contexts. So you drew all these wonderful little circles here, right? Which is your solution space. How is it that you're going to solve a particular problem? Okay. Now, how do they communicate with one another? These are called contracts. So bounded contexts need to communicate with each other. How is it that they're going to communicate with each other? Okay. And why do we have this? Because they have different languages, right? One has a different lead from another, right? Hey, you going to the football game? Right? If you ask me and you're like a soccer fan, or you're like, hey, you want to go to a football game? I'm going to be like, heck yeah, let's go watch the Indianapolis Colts. And you'll be like, what are you talking about, man? I'm like, what are you talking about? Right? And so the same thing happens with these bounded contexts. Hey, I have this thing. I'm going to communicate that to you. The other bounded context could just say, I don't know what you're talking about, right? Because they have their own particular kind of like sub-business language. And so that's where these come in. You could have a partnership, and a partnership is, I have two bounded contexts. They get along really well. They're in the same geographic region. They cooperate, no drama, no conflicts. And maybe that's a relationship between them. Maybe the language isn't so different. That's the way that's going to be linked up with each other, okay? So no interest in blocking each other for that, okay? So that's a partnership. Commitment, continuous integration. Teams are both geographically in the same location. So that's just a relationship that two bounded contexts have. The other one is a shared kernel or a shared model. You derive two bounded contexts and you have an authorization model in between, okay? This could be a library. This could be any sort of system that you wish to make, or it could just be code that is referred to by both particular bounded contexts. These are sometimes typically avoided, but sometimes you have no other choice. Maybe you have a custom authentication authorization model. Maybe you have like certain libraries. So in order to do this, tight CI/CD. But we do know that violates the independence rule. But this can be used as a migratory tool to either combine bounded contexts or split them up. Okay? But typically you have a fight. And I shouldn't say that in a negative way, but that's the way it is, right? Remember, some of these represent a core subdomain, which is the hard stuff, but it's also the stuff that brings your company money, right? One of these is going to win. So one of these is part of a core subdomain that has a lot of hold within your company. And if the other one is based on the other one, part of the other subdomain, I forgot what it was. Generic and supporting. Yeah, supporting. There we go. Good job, brain. But anyways, if one of these bounded contexts was a part of supporting, right, that's going to definitely lose out on one bounded context who has a more political clout. Okay? And so how do you go about doing that? One is conforming. Let's say the upper hand here, this upper bounded context here, has a part of the core subdomain, more powerful, and what they say goes, right? What's the other one going to do? Well, one option is, okay, I'll just do whatever you tell me. So think like a REST API, right? The upper hand has a REST API. The other one says, can you change that for me? The upstream one will say, no, I'm not changing that. So the downstream, would then have to just conform to it. That's a decision you would make. The other one's an anti-corruption layer, which I think many use, and you've been using this even though you probably didn't know what an anti-corruption layer is. And so these could be like RESTful calls, or these could be the way messages come into Kafka, right? That's how we link these together. Well, if I don't like the way that message is looking, that's where I can use an anti-corruption layer. Change the schema around. If I'm getting this big payload of 100 fields and I only need 5 of them, I'm going to just like get rid of all those. That's an anti-corruption layer. Okay? So, not willing to conform, but you want to change the way that that's done. Tomorrow I'm going to be talking about the ports and adapters architecture, which is a nicely fitting architecture for something like this. Okay? All right. So, lots of different reasons for that. Let me just skip ahead. Open host service is the upper service. Upstream service is, wanting to be nice. Here you go. Right? And I will provide different languages for you to interact with. And that's where an open host service comes in. Okay? It will use a published language that is agreed upon. And so any client can communicate with that. That's called a PL. Okay? And that could serve multiple host protocols. So one of the things I want to show you is, so we picked up quite a bit already. And one of the items here is something called context mapper. I don't know if you've ever seen that one. Here's context mapper. And here it is. Kind of cool. Oh, and here's where it comes from. So I'm going to come in over here. Let's and go context mapper. No, maybe not. Oh, I don't have internet on right now, but that's okay. So what context mapper is this. Okay, pretty cool, right? I have a context map, contains cargo, voyage, and planning. And look at that right there. This is a language called CML. And what you could do with this CML is bind these contexts together. So shared kernel to shared kernel, right? Cargo has a shared kernel with voyage planning, okay? This one has an upstream, or location context is an upstream. And then you could describe your bounded context. Here's another one that's a little bit more filled in here, but you kind of get the idea of what this is. It's a language that you can commit into your source code. And really what the great thing is, see that OHS? That was the open host service with the published language, okay? CF means conforming. So customer core has an open host service, a published language, and on the other side, it will conform to what that open host service has. And we'll talk about aggregates here shortly. So what does this do? Well, it generates stuff like this. So once you have that language in there, it's just a case of running an executable, and it creates these wonderful maps for you. So this becomes your source of truth. Is that amazing? Okay. That one's called context mapper, is what that's called. Here's an example here really quick of what Cucumber is. If you've not seen that one before, and here it is. So let's go to resources here. And here's an example of that given when then that I was talking about earlier, right? It's runnable. IntelliJ has these nice little runnable items here. And then inevitably what that gets posted to are these marketing steps in here. So here's an example. Like, what is a prospect? What happens when they submit a form? You know, what happens for the email, and how do we know that that email is sent? And you could see over here like that given a prospect is right over here, okay? So that wires in your business rules, and that's how you could validate you're actually doing things for the business, okay? I'm going to skip ahead because I didn't realize, you know, how much fun I was having. And let me go to the complex here. Well, let me just state here, there are two kinds of ways that you could develop applications. I'll just quickly go through this one, and then I'll go through the complicated ones. This one's called simple business logic, and there are different techniques or patterns that you can use for applications that are of a supporting nature, right? I talked about junior programmers need, you know, to be a part of everything, and you need to hire junior programmers to do items. Well, how is it that they're going to develop apps? Well, they'll either do transaction scripts or active records. And here, let me just cut to the chase here as to what those are. A transaction script is really just this, right? They create a service, and here it is. With a particular connection, here I have, you know, turning off the auto commit because I want to do my own commit. And, you know, they write whatever, you know, they need to, you know, go to a particular database. And whatever goes to the database, since they're just creating very simple CRUD apps, that's what they do, right? And so for the simple apps, you don't have to give them anything complex, but, you know, general CRUD-based applications, you know, it's a good starting point. They get to understand the domain, and that's where that comes. And so, you know, you can have records and other things like that. The other one I was going to mention is this one right up over here. This one's a active record. Has anyone heard of eBean before? eBean does the active record pattern. Quarkus has an amazing one called Panache. Panache is really awesome as well. But here, let's take a look at this one. The last kind of like repository that I showed you was one that was just purely based on JDBC. But this is what a active record will do, right? Junior programmer can totally get into this where they could have a database. And the thing about an active record is that they have nice querying language like this, like find, where. You could even consider JPA as, I know it's not technically a record pattern, but, you know, highly useful as well. And find one of these. Here's the persist right over here. So they could do these things and manage these things. And, you know, great for junior developers to do. Okay. And again, these are going to be bounded contexts that are simple and great for supporting subdomains, AKA your junior developers. Cool, right? Two different kinds right over there. But where I want to spend the rest of my time here is this one. Sorry, I thought I'd have a little bit more time, but that's all right. the complex. And this is going to lead into the talk that I'll have, I think, tomorrow, called ports and adapters. So for the complex stuff, this is where the domain model pattern comes in, okay? And tomorrow I'll talk about ports and adapters. It's one of my favorite topics. But the domain model pattern is what happens when things are complex. What if you're writing software that is a part of the core subdomain? How do we go about dealing with that? Okay. So we deal with a few patterns here: aggregates, value objects, domain events, domain services, and I needed to include their application services. But those are good technical patterns. So we're getting our hands dirty here. Everything must adhere to the ubiquitous language. Okay. So these are the software artifacts that we talk about in domain-driven design. Let's talk about these because I think these are going to be greatly important. Value objects, yes. Okay. Value objects do not have identity. Big point, right? Color, red, green, and blue. One of my favorite projects, and I wish I had signed on to the internet, but too late now. I do a lot of Scala. There's a project called Squance, but it's fantastic. It's weights and measures and units and other things like that, where they use a value object, right? If I have kilowatts, something that is a kilowatt, I'll have an object that represents that. And internally, it houses everything that has to do with kilowatts and electricity. So I don't really have to think about it. That's what a value object is. But no identity is going to be one of the big things about it. Project Valhalla, I think it's Valhalla in Java, they're coming out with something called value. So in Java, you'll have a keyword called value next to a record. And what that's going to do is it's going to inline all the primitives to make it really, really lightweight. So we're doing more and more of this. It's called a value object. And DDD was doing this back in 2003. So fantastic. But entities have an identifier, okay? Right? If two employees have the same name within the company, how do you disambiguate them? This is where you'll need an ID to disambiguate them, right? People in a country, we have social security number in the US, right? That's how we disambiguate items, okay? So entities are really big as well. And you're like, okay, big deal. We use entities all the time, right? In Spring, I do @entity. That's a JPA thing. This is more of a business thing. And sometimes, hard to pick out between the two, but that's the idea here. The power, and here we go, the power of what we do in DDD is burst. Let me slow down on this one because it's the important part. Is based on the aggregate. The aggregate, you may think of aggregate as like, hey, an album has some tracks associated with it where we add a track and we get some tracks with it. But the idea about this is that there is a aggregate boundary around it. And you focus on that particular aggregate. Okay, and so I'll show you an example of that as to what that aggregate is, but it's a very important point, and I have one other slide that will just totally bring it home for you. So stay with me here, but an aggregate is, you have one domain object, and that's related to other, domain objects that has control over. Let me just state here, we don't want a overly complex object graph, right? That's the entire point of it. It has to end somewhere. And because I don't want one class that has to refer to this class and refer to that class and refer to that class. Go all the way. We want it nice and tight because it's easier to reason with, easier to test, etc. But we want to add to this a domain event. Domain events represent something that has just occurred in a past tense form, okay? So those are objects that just essentially record behavior of things that have happened. So an aggregate can emit these domain events, and whoever's interested in them can react. And those can in turn, become messages that you use for EDA, right? Event-driven architecture. And this is why it's the cornerstone of just about everything, okay? And here's my favorite image from learning domain-driven design, which really highlights how you design a particular aggregate. And here it is. Ticket has a message and has an attachment. As far as the object graph is concerned, ticket owns a message object and message object owns a attachment object. But everything else is an ID. That is loaded later. That's what an aggregate provides us. So now I don't have to go chasing everything and create an object graph for everything. I have nicely dividable aggregates. And here's where it is. You keep the aggregates small, useful, and here it is. Public class ticket, I have user ID for the customer. Here's product ID, right? In this image here, I don't want to deal with the customer as an object graph. I don't want a direct link to it. I'm just referring to it by the ID. The list of products, that's external to that green area there. That's eventually consistent. I could load that later, called reify, and I could reify that later. Here's the user ID for the assigned agent. There's the agent right down there. Reified later. But ticket, message, and attachment, those are real, right? And I decide to use that as an object graph. Everything else is lazily loaded, okay? That is so tremendously helpful. And then you have things like domain services, which don't have state, and it's how you bring two aggregates together. It's called a domain service. It's part of your domain. You have your application service, which brings in a repository where you can persist a particular order. Let's see how this looks with code. And so that way we get a nice little idea for this. Let me go to aggregates over here. And you'll see just about everything that I was referring to. Let's take a look at order, where I have an order aggregate here. I have, quite a few classes in here, but the idea for this is, here's the order, where I decided an order has multiple order items associated with it. I decided that those are just going to be the only objects that I have here. And if I take a look at order items, here's that order item. Notice here I'm not referring to an actual product. I'm just referring to the product ID, right? I could load that later. And a lot of times I don't even need that product, because if I'm going to show this up on a website, it's only likely going to be an ID unless I really do need the name. Then I'll go and bring that name in or find some way to bring that in on the application service. But this is what it defines, right? If you ever racked your brain on like, how do I design this, right? This has clear definitions on how you do that, okay? And again, easy to develop and easy to debug. That's the idea for that. Let me not ruin my code. And let me come back to order. So one of the items that I have here are my domain events, right? So if someone creates an order, here's an example here. I'm tracking events as they happen. So this is owning these items called domain events. And keep an ear out for that. These are called domain events. So if someone creates an order, I'm tracking that event there. If someone cancels an order, I'm tracking that event here. If, let's see, if someone submits an order, here's where that is, okay? Now, take a look here. If I find out, and here's the thing, I track everything within this aggregate. If someone cancels an order, or submits an order while the order is in a canceled state, I'll throw an illegal state exception. See how everything's focused on that domain there? Nice and clean, right? That's the idea. And that's what we want to get to. And you get this domain event, right? So these aggregates here will also generate essentially events, and they are past tense. An order item has been added. An order has been submitted. An order has been created. And they are being added to this event here. If I decide to take these order events and send them to Kafka, they're already a part of my aggregate, and I'm tracking every behavior as it happens within the aggregate. Oh, beautiful. And I may run out of time on this one, but at least let me cover a couple of these here. And that is, this could lead very nicely to something called event storming, and I'll leave it here. So event storming is, we know what these aggregates are and items like that. Since I have a few minutes here, let me just get to the point. Those domain events that I was just showing you, like whenever you create an order and things like that, this is something to where, like, if you've gotten used to DDD and how to design the software, you could lead what's called an event storm. And the event storm is, hey, let's take these Post-it notes and look how they're past tense. These are events that have happened, right? The software hasn't been designed yet for this kind of phase, but you know what these are. And then the idea for this is you line them up based on time, right? This comes first and that comes first, and then comes that one, and you line all these events up. Okay, that's the idea for this. You know what a domain event is? That's what these orange stickies are. And then what you could do is you can add other stickies for what these do. So for example, what's a pain point? Well, we don't know how this flight fare is booked and how our prices compared. We don't know yet. That's a pain point. Okay. But one of the really exciting things about doing this kind of event is this. There are going to be events that you will see that you recognize as, after that one point, a different team handles it. So shopping cart initialized. Who handles that? The customer. But once the order has been initialized, who handles that? Well, whoever manages orders. After the order is shipped, who handles that? Maybe a shipping company. After the order is delivered, who handles that, right? And you'll find here that different teams, after certain critical events happen, are handed off to different teams. And this is going to be an indication as to what the bounded context is. So if you need a little bit of help into finding out what the bounded contexts are, do up this session here and use it as a way to find out what those bounded contexts are. Okay? So great. There are also other kinds of stickers, which is, you have a command called submit order. You have a customer that will issue a command that will trigger all these different kinds of domain events, right? This right here is a policy, which is an automation. And you have different stickers, there isn't really that much. Read model is just like a database that you're reading on. Customer will take a look at their shopping cart and then issue a command called submit order, which would trigger all these different kinds of domain events. This is an external system, pink. So CRM will either issue a command, or maybe a shipment approval comes in and you have an automated policy that would trigger off of that and do something with the CRM. Okay, so a little taste of what that is. That's, that is, a part of event storming and finding out what those events are. And this leads to just a lot of things. And, I'll finish on this note right over here. And that is, why do you want to know about it? And I'll just take the last couple of minutes here. You hear a lot about maybe CQRS. How many of you have heard of that one? CQRS, DDD, right? How do we find out how we do our CQRS? That's an architectural concern. DDD helps out with that, right? Because you get a materialized view of the data. How many of you have heard of DataMesh? You may hear about that throughout this particular conference. DataMesh is let's not do data warehouses, let's not do data lakes anymore. Let's bring that into our bounded context. And they actually use the word bounded context, not really microservice, but bounded context. And the idea for a data mesh, and here I just have a few seconds here, but let's get a view on this here, which I had readily available. This is like a Spotify type of company here. The O is things that you interact with. But every one of these bounded contexts has a D associated with it. So you don't have data warehousing, you don't have data lakes. If you need data, you go to where the bounded context is, which is great because your teams now are more than just programmers and data engineers, data specialists, data scientists, and the people who know really a lot about that data. Okay? All right. I try to shove like a really big concept in a 1 hour short time. But if you have any questions or anything, I'll stick around, and I hope you got a lot out of this, so that way you can get started right away with DDD. Thanks, everyone.